No. It always is memorable. Awesome, thank you.
Yeah. There are like 2 of them where I did like -0 and then I realized I like rounded something wrong, so I just like crossed it. Literally everyone got it wrong though, so like the people who rounded and were off by like 1/100th would not like literally. There were like 2 -0s or something. Very bad.
Very bad. Alright guys, 9 more! Infinite limits! I don't think it's in the packet. I was gonna say, are you running out of paper? I think it's perfect. Well, yeah.
Oh no, I don't like that.
What? Normal amount? We're not doing 2 sections today. Come on. Alright guys, you have your title? Alright guys, ready? Jot down these first ones. You missed the title page? Come on, guys.
Good start, good start.
Off to super stuff. So guys, this is, remember what we were just talking about, this is the whole top heavy, bottom heavy, or equal. Okay. So for the first one, what would you tell me? Would you say top heavy, bottom heavy, or equal?
Equal.
Equal. Okay, and remember we only look at this part. Alright, we look at the exponent. Then, when they are equal, remember we divide leading coefficients. So what's 2 divided by 1? 2. So y equals 2. That's the equation of your horizontal asymptote. Okay? That's it. I know. Alright, number 2, is that top heavy, bottom heavy, or equal? Okay, bottom heavy is the easy one. It's always just y equals 0. Alright, then the last one here. What's that? That's going to be a slant asymptote, right? Do you guys remember how to do the division? Could I do synthetic division on this one? Yes. 1, 2, 3, 0. Do I care about the remainder? It's nice that it's 0 this time, but does it matter? No. So what is my equation of my slant asymptote going to be? X plus 3. Okay. So that's somewhat familiar to you guys, right? Okay. Just leaving. Okay. Sorry, Roz. Okay. It's just a rough day. Alright, so we're good with horizontal, slant asymptotes, all of that stuff, right? Okay. So, let's look at this in terms of limits. I don't know why I scribbled all of these out. Well, yeah, we'll just do that one. That's fine. Okay. Wow. Would you like the notes to be in dotted lines?
Yeah.
I could make them really skinny dotted lines so you wouldn't notice them too much. It's pizzazz. We'll mix up two things here. All right, guys. So what this is talking about, this first one, we've got 1 over x. And I'm asking you as x approaches infinity. Anytime I'm talking about x going towards infinity or negative infinity, that is like the end behavior of your graph. Okay? So if you have a horizontal asymptote, it's going to follow that. Or if it's just like a parabola or, you know, cube, remember all of those end behavior things, it could follow that too. So this one, 1 over x, we need to think about top heavy, bottom heavy, or equal. So what would you think on this one? Bottom heavy, so what's my horizontal asymptote going to be? 0. So that, I don't care what the rest of the graph looks like. I know I have a horizontal asymptote at 0. So as x goes to infinity, where is my graph going towards? 0. So the answer is equals 0. I don't know that I can handle the dotted line. All right, let's try, let me just write another one for you. Let's do the limit as x approaches negative infinity of 3x squared minus 2 over 2x squared plus 1. Again, you don't have to draw the entire graph, but if you were thinking about the graph, where would the horizontal asymptote be on this one? 3 halves, yeah, so somewhere in the middle there, okay? So as my graph went towards negative infinity, went way far to the left, where is it going towards? 3 halves. So let's say, sure, let's make one up that's not. Let's do the limit as x approaches infinity of x cubed plus 2x squared minus 7x plus 1. Sorry, I'll move it up a little for you. Can you guys see that okay? It's not a rational function, right? There's no fraction, so we aren't thinking about an asymptote here. Just think, remember, like odd and even, what do the ends do? So you look at your biggest exponent, which is, I know, it all, look at that, all circling back together. This is your biggest exponent, right?
Yes.
So I'm thinking about that, right? Is that exactly what my graph looks like? No, but that's okay. And then dividing by 1 is going to give you the exact. What do you think? As x approaches infinity, where's my graph going? That's it. Wait, where to go, Felipe? Okay. No. So remember we talked about last time, if this is infinity, what x is approaching, this can be infinity. If x is approaching a number like 3, then you can't have infinity alone as an answer. Okay. Yeah, good question. All right. We okay with that? So, you don't need to write this. I'm debating on if I even want to give you any more of these or if we should just do some whiteboard practice. That's what I'm thinking. Yeah, I mean, really, the rest is all just practice. And I think we can just do it. Let's do this one, okay? We'll do one more. This is kind of what you were doing on your homework anyway. So, what am I on, number 4? All of this will be 4. Which, this is like number 15 from the homework you guys did last night. Remember we did that, going over it, making the graph. So really I'm asking you the same question 4 times. It's just from the right, from the left, and overall. I'm reminding you that to get the overall limit, you have to think about from the left and from the right. Yes, these are the same. Do not have to write it twice if you don't want to. This was apparently the progression of my thought. Okay, I'm asking you this, go through these, and then you can All right, so let's think about the graph of this. Because do you guys agree we can't just plug the 2 in? Yeah, that would not be good, right? Okay, so if I'm graphing this rational function, I know that there's a vertical asymptote somewhere. Where is it? Vertical asymptote. 2. It's a rational function, so I also have a horizontal asymptote. Where is that? 1, yes. Why are we saying oh no? Is there trouble?
No.
That's fine. Okay. That's okay. All right. So let's make a little table here just so we can think about what's happening with the graph. Again, I don't need a lot of points. I need just enough so that I know where on the graph I'm going. So let's plug in a 1 for x. What do I get? Yeah. So 1 is -1. Is that enough to tell me where that part of the graph is? It is, actually. It's fine. Like, obviously, if you were doing this for me grading the graph, you'd need a little more going on than that. But just for you to think about where it's going as x approaches 2, that's fine, because it's going to follow the asymptote, so it's got to do this. Okay? What else do you want to plug in? 3. What do I get when I plug in a 3? 3. So that's up here. Is that enough to tell me what that part of the graph is doing? Yes. You guys see how that's not as scary as it looks? Kind of. All right. Once you have your graph drawn, then the limit part is really easy. So as x approaches 2 from the left, well, coming from the left, where am I going? -∞, comma? Okay, good. This is really bad. All right, what about 2 from the right? And does not exist, right? Okay, then your overall limit just does not exist. Opposite direction, so you can't tell me anything other than does not exist. Okay? All right, we'll call that the end of notes. That's the end. The end of notes.
Forever.
Well, for this year.
Wow.
Round of applause.
Why did you wake up then?
A little bit.
What? We just